Now, before we get deep into section 5, I want to make a huge pay attention. The difference between section 4 and section 5 is a matter of an expression versus an equation, and we have different rules for handling those fractions if you're dealing with an expression or if you're dealing with an equation. So this is an expression, and you must keep your denominator because we don't have a way to balance. Golden rule of algebra is what you do to one side of an equation, you do to the other side of the equation, and that's keeping it balanced. So you're not gaining or losing value. You're not changing your expression, changing the value of your equations. When I have expressions, I can't make that balance. So anything I do can't change the value of this expression. If you look at this, because of this little equal sign, this now becomes an equation, and we can get rid of the denominators. We're going to follow a pattern. We can't just throw them out, but you're going to be able to clear the fractions and get rid of those denominators and do some different solving. When we talk expressions, we talk about simplifying, or we do operations. When we talk about equations, we talk about solving. You actually can say R is equal to something, and that is the point with equations. We can boil that variable down. So just really be careful which section you're in and whether or not you have an equation or expression because the rules change. So the first thing we have to talk about is this restrictions on the variable. This is a key point because this is a point on the test. So basically, restrictions on the variable is what can't the denominator be? Well, we know that you can never have 0 in the denominator of a fraction. That's bad. It's bad math grammar and it can't happen. So what we always want to do is we need to find out those values of x, what values of the variable would make this happen. And so you're going to set your denominator equal to 0 and solve. So you're going to have this little baby problem you have to do off to the side. The answers are the restrictions. And you either can say excluded values and list them, or you could say x can't be, and you can give your numbers. So for example, I'm going to figure out what my least common denominator is. My least common denominator here in number 5 is 2x. So we're still doing that. So now to find my excluded value, what would make 2x equal 0? What value would make that happen? So set the denominator equal to 0, and I'm going to solve. So I'm going to divide both sides by 2. And my excluded value is 0. X cannot be 0. So I can either write it that way, or I can say excluded value is 0. So I put that off to the side. Now I'm going to go ahead, and here comes the new part. We're going to build this common denominator. So 2x, first part is good. This part, I'm missing a 2, top and bottom. This one is good. Now that I have built the common denominator, this is a difference. I can throw it out because if the denominators are equal, the numerators are equal. And I'm left with x plus 1 plus 2 equals 1. Combine like terms on the same side of the equation. X plus 3 equals 1. Subtract 3 from both sides. X is equal to negative 2. This is not in my excluded value list, so that is your answer. Okay. Let's look at number 12. Denominators are far more complex, so you need to factor that denominator. You need to factor this first. So I'm going to write it off to the side. The reason I want to factor it is this n plus 5 factor might show up again. And I don't want to use, for example, if I had 1 and 4 plus 1, 6. I could use 24 for a common denominator, but it would be too big and I would have to reduce more at the end. 12 would be more appropriate. So I'm not doubling up on my factors. So that's what I need to do here. So I need to think about what factors of 10. Remember how I said factoring is the backbone? Would add or subtract to make -7. Clearly -2 and -5. I'm going to group, take your common factor of an n out, n minus 2. Remember when the third term is negative, I'm going to pull a negative out. -5 is my common factor. 10 divided by -5 is -2. Now my -2's are my common factors. So this factors into n minus 2, n minus 5, as does this one. Now I can see what my common denominator is. So my least common denominator is going to be that n minus 5 factor and an n minus 2 factor. So the first two terms are good. They have what they need. The last term needs an n minus 2 times an n minus 2. So now I have my common denominator built. But I also have to look at my excluded values. So what would make n minus 5 and n minus 2, what would make that denominator equal 0? Well, if n minus 5 were equal to 0, or if n minus 2 equals 0, if n is equal to 5, or if n is equal to 2. Those are my excluded values. N can't be 5 and n can't be 2. You have to write that and list that off to the side. Now we're ready. Common denominator built. I can throw it out and I'm left with 1 is equal to 2 plus n minus 2. And when I combine my like terms on this side of the equation, I'm left with 1 is equal to n. Double check, it's not one of my excluded values. So this is my answer. If I would get down to the end, let's say I'd gotten down to the bottom and I said n was 2. Because that's an excluded value, I would have to cross that off as a potential answer. So you always have to be certain that your answers are not showing up as your excluded values. Just to take a peek at number 14, this initially looks kind of strange. So my least common denominator here is n minus 6 because whole numbers are over 1. So now when I go to build that common denominator, this first one would need an n minus 6 and the second one would need n minus 6. I also have to look at my excluded values. What would make n minus 6 equal 0? Well, that is if n is 6, so my excluded value is 6. Built my common denominator, go ahead and throw it out. I have n minus 6 plus 1 equals 6. Add those together, n minus 5 equals 6. Add 5 to both sides, and n is equal to 11. Not my excluded value, so that is my answer. So you're going to get good practice with factoring, and don't forget to check for those excluded values. So kind of your summary is 1, factor your denominators if necessary. 2, find your least common denominator. Find your excluded values. Solve for the variable. And kind of a sub-point under here is check solution. And there might be more than one. with excluded values and then cross those off if they exist.